All right, so we're on to 1A.7 Part B, modeling with quadratics. So this time we're now going to take based on a real world problem, create models and go from there. Does that make sense? Okay, so let's get this show on the road. Cricket, get the backs. Here we go. So maximizing the area of an animal pen. All right. We have a farmer here, and this farmer has 2,400 feet of fencing and needs to build a rectangular pen to fence in her animal for grazing. The farmer hires you to help her determine the dimensions of the pen, enclosing the greatest area that can be constructed with available fencing. Right. Okay. So if I am given fencing, mathematically, this represents what? The, the amount of feet I have for fencing represents the what? Yes. Thank you, Jules. You're the first person to say that, by the way. Good job. It represents your perimeter. Okay. So we know that our total perimeter has to equal 2,400. Does that make sense? Okay. And if we remember for a rectangle, the perimeter of a rectangle equals 2 lengths plus 2W. Does that ring a bell? Yeah. Okay. So in your groups, or by yourself, if you're by yourself, you're coming with 3 possible rectangular pins that uses all 2,400 feet. And then we're going to come back together. Okay. So you're going to draw and write out your dimensions. Does that make sense? So you're going to draw your different pins and write out the dimensions. And then we're going to come back together and talk about what we all came up with. Got it? All right. I'm going to give you like 2 minutes to make 3 rectangles with their dimensions. But the key thing is, as Jules reminded us, we have to maximize and use all of our perimeter that's given. Okay? Yes? All right. And go. All right. So let's see how we did. So I'm going to ask each group to give me a rectangle. If your group's rectangle has already been given, then give me another one. Okay? That's why you have 3 of them. So hopefully, as I call on the groups, everyone can give me their own, right? All right. So group 1, what was a dimension of one of your rectangles? 700 and 500. So we have a 700 by 500. All right. Filling by yourself. What'd you get? Group 2, representing. That's okay. Just try. Perfect. You said 600 by 600. All right, Joe, representing group 3. What'd you got? And 800. Does that use all of it though? Does the 800 by 200 use all of my perimeter though? It would have to be the 800 by the 400. There we go. Remember, we have to use all of our perimeter. Pretend that's a straight line. You got to use all the perimeter. So if we did the 800 by 200, then we wouldn't use all of our perimeter. But all right, group 4, you have another one to give me? 1,000 by 200. We have a 1,000 by 200. All right, group 5, what we got? Okay. Oh, really? Okay. Um, so we have 1,150 by 50. Okay, okay. It's that's the best I can do. Group 6. All of them? Oh, we have a 750 by 450. All right. So as you can see, there are infinite possibilities, right? We could keep drawing and keep drawing, and we're like, oh my gosh, how can I represent this? Infinite possibilities. That must mean I can make a what? Make a Starts with an a function. That means I can make a function, weirdos. Okay? I can make a function, right? Because the purpose of a function is for us to be able to see over time a larger scale of what's taking place. Does that make sense? So in this case, it would keep going and going and going. All right. In order to make our function, we have to start with creating a table, correct? So we're going to make a 3-column table. And in this 3-column table, we're going to write out our width, our length, and our area. Okay. For this, we're writing the area because she wants, obviously, to maximize, right? Now, I'm not judging Rachel or anything, but her little baby design right here, that 1150 by 50 does that appear to be the maximum area? No, it does not. In case y'all are wondering, it's very tiny. I don't know why no one could say no, Miss Jones. That's not the biggest area. Uh, all right, so she wants to maximize. So remember that when you're finding the area of a rectangle equals your length times your width, right? Okay, so in this case, when we're creating our table, we have our widths. So we're going to write our width values. We're going to have our lengths. And then we're going to find the area, which equals our length times our width. Okay. So the first values that we were given were 500 by 700, correct? So we have a 500 by 700, which means that this is 350,000. Agree? Is it okay if I don't write all the zeros? I'm going to do the social media K. All right. The next one that we came up with as a class was 600 by 600. So we had a 600 by 600, which would be 360K. Still with me? All right. Our next one that we came up with was a 400 by 800. So our width was 400 and our length was 800, which would put us at 320K. Okay, going back again, we had our 200 by 1,000. So 200 by 1,000. And a 200 by 1,000 is going to give us what? 200,000. 200K. Okay. Then we had was this the baby one? The 50 by 1150. Is what? 2040? Oh, 400. Oh. I just don't know. It ruins my pattern of writing things, by the way. No, it's fine. I'll write it. 2,400. Is that what was that? Are you sure? 11 big times 50? Okay. It sounds about right. All right, next we're at 450 by 750 now. Someone will have to do that one for us. We're building a table. All right, what do we get for 450 by 750? $450 times 750. Somebody's gonna tell me. Thank you. Okay, so now we have a table of data. All right. Before we go any further, I want to talk about the fact that we could build our own model here, right? What's the relationship between our width and our length? We know that together they have to equal what? Together they have to equal 1,200. The width and the length together have to be 1,200, right? That's because it's half of the rectangle. Those are our dimensions. So we know that together our width plus our length has to equal 1,200. Does that make sense? So if we have our width, That means that our length equals, L would equal 1200 minus W, correct? Do y'all agree with me? So these are the values that we just created. So if you look at each one of these, if I have 500 to find the length, that was 1200 minus 500, which is 700, right? If you look right here, we have 600 as my width. 1200 minus 600 is 600. Erase that little random pet speck. If we had 400, 1200 minus 400 is 800. We have 200, 1200 minus 200 is 1000. Do y'all see that relationship? So if I wanted to build without a calculator, a formula using the fact that I know area equals length times width, could I create a rule for that? Yes, because I can substitute my length in with 1200 minus W. So for area, it would equal, instead of L, we would have 1200 minus W times W. And this would be our area formula. So no matter what the width is, we can then determine which value would be our outcome of our area, right? What type of function is that? W times W would make what? W times W equals W squared. A squared function is called a, we just took notes over it. Makes and that's called a quadratic. Okay. When you have a W squared, that is a quadratic function, right? So this would ultimately create a quadratic function. All right. We're going to prove that we did this correctly by going on to part 2. Part 2 is where we're going to be using Desmos to model this. All right. So in Desmos, we're going to talk about the ability to put in more than one Y. Now, because Desmos has updated, guess what we don't need anymore? We don't need this anymore, okay? The reason why we don't need that anymore is because of the regression tool. So remember, your regression bar tool looks like this, okay? They also added the feature to the testing calculator where we can toggle between our different X's. So in our values, I'm not going to rewrite our table, right? But our W, that's going to be our X. Does that make sense? Okay. We're going to have W equals X. Our Y1, that's going to be our length. And now we're going to be adding in a Y2, and that's going to be our area values. Okay. So we're going to type these into Desmos. So I'm going to open up our Desmos. All right, I would like to show y'all that on your page, I don't know if you noticed or not, so you don't have to go into your modules or anything, even though it's there. Go, we're gonna open it. I'm here now, but once it's regular, you won't have to. Do you guys see right there? I put the little Desmos key and you just click on it. It's going to take you to our Desmos graph. Once we're in our Desmos graph, we're going to go ahead and build our table. We're going to have X1, Y1, and we're going to type in Y2. You're literally going to make sure it's all lowercase y, and we're going to type in Y2. Now we're going to type in the values that we found on our table, that we created from our table. So our values, these are what we're going to type in. Got it? Okay. So we're going to type in these values. So we had 500, 600, 400, 200, 50, and 450. Then we had 700, 600, 800, 1000, 1150, and then we had 750. And then for our area, we had 350,000, 350,000. Then we had 360,000. Then we had 320,000. 200,000? 200, 400,000? That still sounds weird to me. That's what I said. That sounds weird. I was like, I'm trying to trust Rachel here, but I don't know what she was telling us. Yeah, 57,500. I was like, that just don't sound right. And I'm just rolling with it. I don't know what she was trying to set us up for. 300. You said I checked like multiple times. That's what we're. No, I was like, what do you mean? And you. All right, so we have all our values in. Remember, we're gonna hit the little. And when we do this, what do you notice? What kind of shape do you see forming? A curve. And what do we call that curve? A, what is it? What's the shape called? Parabola. We see our parabola. So when we come over here to click on our regression, we know that we're switching it to a quadratic. Okay. That parabola curve is coming from our y2. So do you see where right here where it says y1? We need to switch it to y2. When we do the little switchy switch, guess what it does? Pew. There you see it. Okay. Did we see it? Are we good? All right. So then it comes up with our equation. So our equation would be y equals negative 1x squared plus 1200x plus 0. Is it necessary to have plus 0? No. Okay. So we're going to come back over here and we're going to talk about our problem, what we got. So we got that our y equals negative x squared plus 1200x, right? For this problem, our y and our x. Our y was y2, right? And that's our area. So area equals, our x was our what? Width, our w, right? So this area equals negative w squared plus 1200x. And that would be our model. Okay. Now, do you guys remember where we wrote ours? Without using the calculator, using just our knowledge of perimeter and area. If I was to distribute, would I get that same answer? Yeah. 1200 times W is 1200 W. W times W is W squared. And when I come down to, I would get the exact same. Oh, and y'all just let me write X. How embarrassing. You saw nothing. Okay. So the difference is that the one we wrote together, we were in factored form. Does that make sense? So the one we wrote together was factored form, and this one is going to be in standard form. So this is the standard form. And the one we wrote together is our factored form. And this is our factored form. But they are the same. Okay, so that's what's going to ask you here. And next is going to ask us, how can you use the regression equation and its graph to determine the greatest area using the available fencing? If I'm looking for the greatest area in terms of a quadratic, that means I'm looking for my maximum value, aka a max vertex. Okay, can we identify our max vertex from our graph? Let's go look. So we go back to our graph and we come over here and it says that our max vertex is at 600, right? So if I have a 600 by 600, I'm going to get what? 360,000. That is the biggest I can make it. So our max vertex is at 600, 360,000. Okay, which means that my width would have to be 600 and your length equals 12 minus your width. So 12 minus 600 means that my length would also have to be 600 feet, right? And our total area would be 360,000 feet squared. Ooh, angle. All right. So the next thing I want to show you is that let's say the problem's asking for your answer in vertex form. Well, with the regression icon that we have now, it doesn't give us vertex form, but we can still ask for the vertex form. Does that make sense? So we can ask for the vertex form by writing in what we want in vertex form. Now, for our problem, our area is not our y1. Our area is our y2. Does that make sense? So instead of putting in y1, we're going to type in y2. Okay? So we're going to ask it for our vertex form. So when you come over here, you're going to type it as y2 tilde, and you're going to type your a parentheses x1, because those are our x values, or what they're called, minus, remember, h and k represents our vertex, to the second power, because that's our vertex form, plus k. So exactly what's written in your notes. And notice it will tell me the values to write my vertex form. Okay, it's not an option here, but you can still command certain formats as your regression model using Desmos. So my function would be I'm just going to write an f of x. F of x equals, it says my a is -1, parentheses, x minus my h. My h is 600 squared, plus my k, and my k is 360,000. Notice that it's the exact same graph, just in a different format. Okay, so now we've modeled all three of our quadratic forms using our example here, right? So I'm going to go back to our notes to write down our vertex form. So our vertex form we had was y2 equals -1 x minus 600 plus 360,000. Remember what each part represents as far as the real world problem. Our y2 represented our area, and our x represents our width, correct? And this is called our vertex form. Okay, so to make sure that you understand what we just did, on part 4, you're going to do a little quick write with some guided questions, okay? So that you take it all in, what we did from all the parts, from part 1 to part 2. You're going to take it all in, and it's asking you, what is the vertex of the parabola? What is the maximum value of the quadratic function? And then interpret all of this to explain for this specific problem, okay? So to make sure that you understand what we did, you're going to internalize and write it in your own words, okay? We've answered all this individually. Now you're putting it together in a sentence, okay? All right.